Hello, space enthusiasts. Today we have an absolutely packed show with some incredible developments from across the cosmic frontier. From groundbreaking solar research during the recent eclipse to fascinating discoveries about distant worlds, we're covering it all. We'll dive into how scientists used the spectacular North American solar eclipse to unlock new secrets about our sun's corona. And we'll look ahead to an exciting Christmas Eve mission that will take us closer to our star than ever before. We've also got some intriguing news about organic compounds found on the dwarf planet Ceres that could have major implications for the search for life, plus a concerning incident with a satellite breakup that's raising important questions about space security. And don't miss our story about an extraordinary exoplanet that's literally leaving a trail through space. It's the kind of discovery that reminds us just how weird and wonderful our universe can be. We've got a lot to cover, so let's get started. Scientists have been making remarkable discoveries about our sun thanks to the recent solar eclipse that swept across North America. When the moon perfectly blocked out the sun's blindingly bright surface, researchers got a rare opportunity to study the mysterious corona, the sun's outer atmosphere that's normally impossible to observe from Earth. The eclipse sparked multiple citizen science initiatives, including an ambitious project called Citizen Kate 2024, which deployed 35 telescopes from Texas all the way to Maine. By combining data from these stations, researchers are creating an unprecedented 60-minute movie showing how the corona changed throughout the eclipse. What makes this project even more special is how it brought together people from all walks of life, from middle school students to retirees, to conduct cutting-edge solar research. Another fascinating project involved over 6,000 amateur radio operators across the continent. By tracking how radio signals behaved during the eclipse, they helped map changes in Earth's ionosphere, the electrically charged layer of our upper atmosphere that's critical for satellite communications. The sudden absence of sunlight during the eclipse created unique conditions that helped scientists better understand how solar radiation affects our planet's atmospheric layers. Weather balloons launched during the eclipse revealed something equally intriguing. The moon's shadow actually generates waves in our atmosphere, similar to ripples in a pond. These atmospheric waves could help improve our weather forecasting models by showing us how different layers of our atmosphere interact. All of this research is about to get even more exciting. On Christmas Eve, NASA's Parker Solar Probe will make its closest approach yet to the sun, diving to within just 6.21 million kilometers of our star's surface. This will put it right in the middle of the corona regions that scientists observed during the eclipse. By combining these different perspectives, from Earth-based eclipse observations to direct measurements from Parker, researchers are building a more complete picture of how our sun works and how it influences life here on Earth. As one NASA scientist put it, it's like different people trying to describe an elephant by touching different parts. The eclipse gives us one view of the corona, while Parker provides another perspective by flying right through it. Together, they're helping us solve the complex puzzle of solar physics and its effects on our planet. Next up, exciting discoveries are emerging from NASA's Dawn mission to Ceres, the largest object in the asteroid belt. Scientists have identified 11 new regions containing organic compounds on this fascinating dwarf planet, suggesting the presence of vast internal reservoirs of organic materials. This finding builds upon the initial 2017 discovery of organic compounds near Ceres' S03E229 crater. What makes this discovery particularly intriguing is that these organic materials appear to be native to Ceres rather than delivered by comets or asteroids, as previously thought. This indicates that Ceres possesses internal energy sources potentially capable of supporting biological processes, making it an even more significant target for astrobiological studies. At over 930 kilometers in diameter, Ceres stands out as the most water-rich body in the inner solar system after Earth. The presence of both water ice and possibly liquid water beneath its surface places it among the ocean worlds that could harbor conditions suitable for life. This combination of water and organic compounds makes Ceres an increasingly compelling destination for future space exploration. The research team employed sophisticated analysis techniques to make these discoveries. They first characterized the compounds in the S03E229 crater, then systematically scanned Ceres' entire surface using high-resolution images from the Dawn spacecraft. Most intriguingly, they found a particularly strong signature of organic materials in the region between the Urvara and Yalode basins, where violent impacts had excavated material from deep within Ceres. Laboratory experiments supporting this research have shown that organic compounds degrade more rapidly under solar radiation than previously thought. Given the quantities of organic materials detected and their observed degradation levels, scientists believe there must be substantial reservoirs of organic compounds beneath Ceres' surface. These findings have significant implications for our understanding of the early solar system and the potential for life-supporting environments beyond Earth. As a remnant from our solar system's formation 4.6 billion years ago, Ceres could provide crucial insights into the distribution of organic materials during planetary formation. Looking to the future, Ceres might even serve as a strategic stopover point for deep space missions, offering valuable resources for space exploration beyond Mars. A concerning development in orbital space has emerged with the breakup of Intelsat 33E in geostationary orbit. Space tracking company Exoanalytic Solutions has identified more than 700 pieces of debris from this incident, which occurred on October 19th. The fragments range dramatically in size, from pieces as small as softballs to others as large as car doors. This event has raised significant concerns about space security. Exoanalytic Solutions Chief Growth Officer warns that such breakups could potentially be exploited by adversaries, as the resulting debris cloud creates substantial noise in tracking systems that could mask other activities in geostationary orbit. The incident marks the second failure in Boeing's series of Epic-Ang high-throughput satellites built for Intelsat. The first satellite in the series, Intelsat 29E, was lost in 2019, following what investigators determined was either a meteoroid impact or a wiring flaw. Boeing is currently investigating the cause of this latest breakup. While the immediate danger from the debris has significantly decreased over recent months, the incident highlights growing challenges in the increasingly contested space domain. Exoanalytic Solutions reports that collision alerts, which initially spiked to 4 times normal levels following the breakup, have now stabilized to typical frequencies. This event coincides with observations of increasing Chinese activities in geostationary orbit, including routine satellite maneuvers and close-up inspections of other satellites. Space tracking experts have noted China's expanding presence in space, with their satellite fleet growing from just 36 in 2010 to more than 1,000 today, adding another layer of complexity to space domain awareness and security concerns. Now, a quick but significant update. Rocket Lab has recently unveiled the purpose behind their secretive November launch, confirming it was a hypersonic technology test for the U.S. Department of Defense. The suborbital mission, which took place on November 24th from Virginia's Wallops Island, utilized their HASTE vehicle, a modified version of their Electron rocket designed specifically for suborbital flights. What makes this mission particularly remarkable is that it was a part of an unprecedented doubleheader for Rocket Lab. Less than 22 hours after the military test, they successfully launched another mission from a completely different hemisphere, deploying 5 Internet of Things satellites for French company Kinéis. The military test flight was conducted under the Multi-Service Advanced Capability Hypersonics Test Bed Project, known as MACH-TB. This initiative aims to expand hypersonic flight testing capabilities for the United States military. Rocket Lab not only provided the launch platform, but also designed and manufactured the experimental hypersonic instrumentation for the mission, completing this on an accelerated timeline. This mission marked only the second flight of the HASTE vehicle, with its debut launch occurring in June 2023 from the same launch facility. The subsequent orbital launch the next day proved equally significant for Rocket Lab, as it pushed their total satellite deployment count past the 200 mark, reaching 203 satellites launched aboard their Electron rocket across 54 successful missions, with 13 of those launches occurring this year alone. Meanwhile, further out in space. In an intriguing astronomical discovery, scientists have identified something quite unusual about the exoplanet WASP-69b. It's sporting a massive tail of gas that stretches more than 350,000 miles behind it. This remarkable feature is actually the planet's atmosphere being slowly stripped away into space, creating a comet-like tail that's more than 7.5 times the planet's radius. The process creating this celestial spectacle is fascinating. WASP-69b is what we call a hot Jupiter, orbiting extremely close to its host star. The intense stellar radiation heats the planet's outer atmosphere so much that lightweight gases like hydrogen and helium are literally being launched into space. But here's where it gets really interesting. Instead of escaping uniformly around the planet, these gases are swept into a tail by the stellar wind from the planet's star, much like how a windsock behaves in a breeze. While losing 200,000 tons of gas per second might sound catastrophic, the planet is actually losing its atmosphere very gradually. To put this in perspective, it takes about 1 billion years for WASP-69b to lose an amount of material equivalent to the mass of Earth. Given that this solar system is around 7 billion years old, the planet has likely lost the equivalent of 7 Earths worth of mass over its lifetime. The tail's exact length remains a mystery, as researchers had to end their observations before the tail's signal completely disappeared. Even more intriguingly, the tail's size and shape can change over time as the stellar wind fluctuates, making it a dynamic feature that could help scientists better understand the complex relationship between stars and their planets. This discovery isn't just a cosmic curiosity. It's providing valuable insights into how planetary atmospheres interact with their host stars and evolve over time. Well, that brings us to the end of today's fascinating journey through space. This is Anna, and I want to thank you for joining me on another episode of Astronomy Daily. From solar studies during the recent eclipse to gas-tailed exoplanets, it's been quite a ride through our cosmic neighborhood. If you've enjoyed today's show and want to stay up to date with all things space and astronomy, I invite you to visit our website at astronomydaily.io. There, you'll find all our back episodes, and you can sign up for our free daily newsletter. We've also got a constantly updating newsfeed to keep you informed about the latest developments in space science. Want to join our growing community of space enthusiasts? You can find us across all major social platforms. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and wondering about the mysteries of our universe. This has been Anna with Astronomy Daily.